Well, hey everybody, Mr. Reeves back with you. And in this video today, we are going to be looking at writing two-step equations, and we're going to review solving two-step equations. So we're actually going to start with the solving part and go back to the writing part. And for the solving part, I'm going to go ahead and start with algebra tiles. All right, so here we go. So I've got a problem right here set up with algebra tiles. 3x minus 4 is equal to 5. You can see here are my three x's. These long green bars are x's. Your textbook uses long yellow ones, but most of the time when you see algebra tiles, x's are green when they're positive and they are red when they're negative. Notice everything over here that's negative is red. And then minus 4, 1, 2, 3, 4, minus 4, same as adding a negative 4. All right, but this represents the minus 4 is equal to 5, 1, 2, 3, 4, 5. And our goal is to solve an equation. Remember, solving an equation is finding the value of the variable that makes the equation true. Solving an equation is finding the value of the variable that makes the equation true. And we do that by getting the variable by itself. We're going to perform inverse operations. Remember, inverse means opposite. So the inverse operations are the opposite operations, and they allow us to get the variable by itself. Remember, the inverse of adding is subtracting, and the inverse of multiplying is dividing. All right, so if you take a look at this side over here, our expression 3x minus 4 is equal to 5 going forwards. They would have multiplied by 3 and subtracted 4, and they got 5 as a result. So going backwards, we're going to start at that 5, then we're going to add 4 on, and then divide by 3. Again, we're going to add 4 on and divide by 3. So here we go. So first thing I'm going to do is add 4 on, okay? So I'm going to come over here, and I'm going to add 1, and then it has this great copy feature. So I now have added 4 on this side, okay? Then I'm going to come over here and put 1. Remember, whatever you do to an equation, you must do to the same thing to both sides to keep it balanced. So now I've added 4 to both sides. You can see there's 4 extra and there's 4 extra. Well, the great thing is that plus 4 and that minus 4, they are inverse operations, so they cancel each other out, okay? So now if you take a look what's left, I now have 3x is equal to 9. 3x is equal to 9. So if I come up here and change this, it's now 3x equals 9, all right? So now I need to divide that into 3 parts, right? I need to divide that into 3 equal parts. So what I'm going to do is take these 9 and dividing with algebra tiles, or dividing with anything physically actually, means putting into like equal groups. Okay, so here we go. So I'm just going to take these and put these into equal groups. And you could see that when I separate those 9 into 3 equal groups, this guy's being stubborn here. All right, come on, there we go. Come on. All right, these guys have a mind of their own. You could see that when 3x's is equal to 9, 1x is equal to 3. I divide that by 3, and I get x is equal to, not 4, Mr. Reeves, 3. X is equal to 3. So that is the answer to our equation. In fact, if we wanted to check it, our original equation was 3x, right, minus 4 was equal to 5. And what were the steps that we took? First, we added 4 to both sides, and that gave us 3x is equal to 9. And then we divided it up into 3 equal groups, and then we got the answer, x is equal to 3. Okay? And then if we were to check our answer, 3 times 3 minus 4, does it in fact equal 5? Well, 3 times 3 is 9. 9 minus 4, 5 equals 5. It checks. That proves that our answer was correct. correct. Okay, let's go to our next problem with algebra tiles. We've got -3 is equal to 5 minus 4x. So right here you can see I've got my -3. Then I've got 1, 2, 3, 4, 5 minus 4x is again red, means it's negative. So you could see over here are the negatives, over here are the positives. Again, what's my goal? My goal is to find out what x is. My goal is to find out what x is, all right? So this one's going to be a little more tricky because I actually have negative x's. But still, let's start by trying to get at least one of these by themselves. Okay, so here I go. I've got 5 positive 1, so I need to make that 5 go away. Now normally we would take away 5 from both sides, but I don't have any over here to take away. So if I add 5 negatives, here we go, 1, and then I'm going to go ahead and copy 2, 3, 4, 5 negatives here. All right, and then I put 5 negatives here, 1, 2, 3, 4, 5. That's like taking away 5, right? Okay, did I get 5 here? I did. So you can see I did the same thing to both sides. All right, adding 5 negatives is like taking 5 positives away, because what happens, these are going to eliminate each other. Okay. All right. Okay, so now what do I have? Well, now I just have the -4x's here, so I can go ahead and take those 5 away. But on the other side, instead of 3 negatives, now I have 8 negatives, okay? And now remember, we want to divide now into 4 equal groups. Okay, so this time I'm going to go ahead and move them underneath here. Remember, dividing is putting in equal groups. I've got 4 groups that I'm going to need. So I'm taking these and putting them into 4 groups, and I think you could see what's going to happen. I'm going to end up with 2 negatives in each group. Okay? All right. So you might think that the answer is equal to -2, but I want us to look at this carefully, okay? If negative x is equal to -2, and our goal is to find out what positive x is, well, that means that positive x would equal +2. All right, so what I would actually do is multiply this entire equation by -1. Remember, solving an equation is finding the value of the variable in its positive case. So if -x equals -2, positive x equals +2, right? What I actually would get if I multiply everything by -1 is, instead of those 4 red ones, I would have 4 green ones, and instead of 8 of the red ones, I would have 8 of the yellow ones. Do you see how that would work? All right, I know the spacing isn't the same, but I don't want to take the time to space it all out. Okay, so if -x equal -2, all right, so this is what we have. We have -x is equal to -2. That means that a positive x, take that negative away on there, would equal a +2. Take that negative away there. And that would be our answer. Okay? So again, if we go back to our original equation was, actually, I don't remember our original equation. That's pretty bad. So it's okay. We won't check it this time. All right, let's go back now to the textbook. All right, I'm going to do a few more problems in review. So I think I want to go to page 191, section 6.4, solving two-step equations. In fact, I'm going to go ahead and go over here to the practice section. Okay, so I'm going to work through some of these problems with you, and then we will get to writing two-step equations. Okay, so here we go. Number 9. 9s plus 3 is equal to 57. So what did they do? They multiplied this unknown number by 9. They added 3, and when they were done, they got 57. So we're going to work backwards, okay? We're going to work backwards. We're going to subtract 3, and then we're going to divide by 9. We're going to subtract 3, and then we're going to divide by 9. And remember, whatever you do to an equation, you do to both sides. All right, so I get 9s is equal to 54. All right, the inverse of multiplying by 9 is dividing by 9. And I'm going to get s is equal to, well, 54 divided by 9 is 6. So 6 should be the value of the variable that makes this equation true. All right, so I'm going to go ahead and go 9 times 6 is 54. 54 plus 3 is 57. It works. Okay? All right, this one right here, number 9. K divided by 2 plus 9 is equal to 30. Again, they divided by 2, and they added 9, and they got an answer of 30. So the first thing I'm going to do is subtract 9. Right? Because the last thing they did was add 9. We're going to do the opposite operations in the opposite order. And then we get K divided by 2 was equal to, or is equal to, 21. They divided by 2, so we need to multiply by 2 because the inverse or opposite of dividing is multiplying. And then I get K is equal to 42. Again, 42 is the value of the variable that makes this equation true. So if I go back to my equation and I do 42 divided by 2 plus 9, it should equal 30. Well, 42 divided by 2 is 21. 21 plus 9 is 30. It checks. Awesome, possum. All right, 2 more. Number 12. They multiplied by negative 9. They subtracted 15, and then they got 93. So what are we going to do? We're going to add 15 to both sides, and then we're going to get negative 9h is equal to, well, when I add 93 to 15, I get 108. And they multiplied by negative 9, so we're going to divide by negative 9. And when I do that, I'm going to get h is equal to negative 12. All right. So now I'm going to go over and check that answer right over here. Let's see what happens. A negative 9 times a negative 12 should equal, when I subtract 15, 93. Well, I get 108, and I take away 15, and guess what I get? I get 93. It works. Okay. All right, and finally, this last one is a little bit different. If you'll notice on this last one, we have a number outside parentheses. We have a number outside parentheses, and we need to solve this equation. So this is not the type of equation we're used to with these two-step equations. Now we have 2 choices. Do you remember us learning the distributive property? All right, the distributive property said if you have a number outside the parentheses, you multiply what's inside the parentheses. 7 times c minus 7 times 12 is 84 is equal to negative 21. And then we're back to just a regular 2-step equation. So like right over here, if I did this one, I can multiply by negative 1/3, and I would get negative 1/3 n minus, because a third of 15, that's going to give me 5, and a positive times a negative is equal to negative 2. So that's the distributive property. So if you distribute, then you simply get that 2-step equation. We would then say, okay, they multiplied by 7 and then subtracted 84. I'm going to go ahead and add 84 to both sides. That gives me 7c is equal to, let's see here, 63, I believe. 63 is a great number to divide by 7 because it goes in evenly, and we get c is equal to 9. And again, if we check it, 7 times 9 minus 12 is supposed to equal negative 21. So 7 times negative 3, all right, equals negative 21. Negative 21 equals negative 21. It checks. All right, now I do want to show you the other way that you could have done this one, although it really wouldn't work on number 13 nearly as well. All right, is if you have a number outside the parentheses, and it does go evenly. Sorry, that's not negative 12. That's supposed to be negative 21, Mr. Reeves. Let's see if we can get the eraser pressed here. All right, negative 21. If this number goes evenly into that number, you can actually divide both sides like so. All right, 7 divided by 7. And then when you do that, you get C minus 12 is equal to negative 3. And then you could add 12 to both sides. And you get C is equal to 9. So you could see we got the same answer by dividing both sides by the number instead of distributing. The problem with that method is it only works well when that number on the right side is a multiple of that factor on the left side. Distributing will always work. So my recommendation is when you have parentheses as part of your equation, when you have parentheses like that, go ahead and just distribute and then solve from there. Simplify before you solve is what I like to say. All right, well, I have decided that we're just going to go ahead and stop this video as a review of solving two-step equations, and then we will go ahead and do a separate video for writing two-step equations. All right, have a great day until next time.